Alright. Chapter 6, Oscillopes and Spectrum Analyzer. Non-resident training course, September 1988, Navy Electricity Electronic Training Series Module 16, Introduction to Test Equipment. Alright, Chapter 6, Oscillope and Spectrum Analysis. Chapter 6, Oscillope and Spectrum Analysis. Learning with Jeff. The completion of the chapter should be able to describe the cathode ray tube used in an oscillope, explain the operation of an oscillope, describe the purpose of the control and indicators found with an oscillope, determine the proper procedure of the dual trace oscillope, describe the accessory probe to be able to use with the dual trace oscillope, explain the operation spectrum analysis, describe the purpose of the control and indicate the function of the spectrum analysis. Introduction, one of the most widely used piece of the electrical test equipment, the oscillope, the shape of the video pulse appearing with the selected equipment test point, with although the oscillope is better, the other accurately showing video pulse, all function and the functional and fundamental the same way. If you learn how to use one oscillope operation, you will be able to learn others. As you will learn in this chapter, there are many different types of the oscillopes, varying in the complexity, the simplicity, the complex. Before we get to the into order to discuss the dual trace oscillope, you will first present the general overview of the basic single trace oscillope operation. Shortly, we'll show the oscillope of the cathode ray tube with the control of the electron beam to give the present of the visual pattern of the graphical data on the fluorescent screen. Another piece of the test equipment for the spectrum analysis, analyze the test equipment used to sweep over the band frequency, determine the frequency of the being produced by the specific circuit under the testing. And then the amplitude of each of the frequency component, the accurately interpretation of the display will allow the determine the efficiency of the equipment being tested. Cathode ray tubes. A detail of the discussion of the cathode ray tubes is presented in the Neets module 6 of the electron emission of the tube with the power supply. Before continuing with the step of the cathode ray tube, the select then you want to review the chapter 2 of the module of the cathode ray tube, with the oscilloscope, tip, the electron gun, deflection system, fluorescent screen. With all of these elements are enclosed over the evacuated space. In the glass cathode ray tube, the electron gun generated the electron focus with the narrow beam, with the deflection show the system of the beam horizontal with the vertical across the screen. The screen is coated with a phosphorus material with the globe then struck with by electron. Figure 6.1 show the construction of the cathode ray tube. Heater, cathode heater control grid, first anode, second anode, vertical deflection plates, horizontal deflection plates, graphite coating. Screen phosphorus coating inside. Electrical gun specifically here for the cathode generate the electrons control grid, the control of the brightness, the controlling electron flow with the two anodes first. Second, with the main purpose of the first focusing of the anode, the focus the electron into the narrow beam of the screen. The second, accelerating anodes accelerate the electron as they pass in the control grid. Cylinder control the small opening of the baffle at one end of the anode, consisted of the two cylinders with containing the baffle of the plate with the small hole in the centers. Cathode control grid, as most of the conventional electron go over the cathode, is indirectly heat with the midst of the cloud with the electron with the control of the get rid of horizontal metal of the tube of the plate over the cathode. The small opening is located at the center of the baffle, and the opposite of the cathode. The control grid is maintained with the negative potential with respect to the cathode to keep the electrons bunched together. High positive the potential of the anodes, both of the electron through the hole of the grid, with the big cup of the grid, with the near of the cathode, the control of the number of the electrons that are emitted. In order A as an ordinary electron with the negative voltage grid at the varied either of the control electron follow with the stop of the complete with the brightness and temperature image of the fluorescent screen that is determined by the number of the electrons striking the screen. This is controlled by the voltage within the control grid, electrostatic licensing lenses and focusing. The electron beam is focused with the two electrostatic field that exists between the control grid of the first anode, between the first and second anode, that show how the electrons beam with the electron come. The electrostatic fields are verted the lens to cover the field of the bend, but the electron stream in the same manner with the optical. Lens bend light ray to the first electrical lens get out the electron across the first focal point within the field, with the second lens behind bends of the spreading stream with the return of them to the new second focal point at the cathode ray tube. Alright, first electrical lens, the grid, the first focal point, and one anode focusing the focus control, second electronic static lens, second anode electron accelerating second focal point screen. As figure 6.2 shows the relatively voltage relationship with electronic gun element of the cathode K is fixed point of the voltage with respect to the ground of the grid is voltage variable negative voltage with the respect of the cathode fixed positive voltage with 7,000 volt with several thousand volts with the connected with the second accelerating anode with the potential of the first focusing anode left the power with the potential of the second anode. First anode can be varied with the plate of the focal point of the electron beam on the screen of the tube of the control grid potential to show the proper level to allow the correct number of electrons through the gun with the desired image intensity. Electron beam deflection. Electron beam to develop the focus with the accelerator of the electron go the beam appears on the screen of the cathode ray tube with a small bright dot with the beam to the left of one position. Electron will assume to be on the way with illuminated coating in one area of the be any with the UV electron beam must be able to move it as the electrostatic field can be able to have the moving electron. As you've seen in the previous illustration, beam of the electron path through the electrostatic field between the two plates. That should remember the electrons are negatively charged as that they will be deflected in the direction of the electronic force for the negative part of the deflection cover of the electron follow the curved path while the electrostatic field, which if the electron leave the electrostatic field, the typical straight path of the screen at the angle of the left of the field because of which they are deflected equally, the electron will be traveling toward the same spot with the proper voltage must exist of the anodes to produce the electrostatic field. The chamber of these voltage chamber the focal point of the beam of the cup of the electro beam to strike the cathode ray tube at a different point. Alright, factors influencing deflection angle. The deflection angle of the outgoing electron beam length of the cathode ray tube, the center of the line axis between the two the plate, depending on the following factor: length of the deflection field, the space between the deflection plate, the difference potential between the plate, the accelerating voltage of the second anode, length of the deflection field with the shown figure 6.3 of the long field with the long deflection has more of the time to exert the deflecting force of the electron beam that does the short field with the short deflection plates. Therefore, the longer the deflection plate can be bent with the beam with the greater deflection angle. Positive and negative of 0 volts and large deflection angle with a small deflection angle. Factors influencing length of the field. Space between the plates is shown in figure 6.4 of the close together of the plate for the more of effort of effect of the electrical force have the deflection angle of the electron beam. Show the space between the plate with the net wide deflection angle of the closing space with the wide space and narrow deflection. The difference of the potential of the plate figure 6.5 can be varied with the inch of the cup with the wider angle and narrow deflection angle with the greater the potential of the wider deflection angle. Wide deflection angle, the high potential load, and narrow deflection angle. The beam acceleration faster electrons are moving smaller than the deflection angle that's shown in the figure 6.6. Wide deflection angle, low acceleration, high acceleration angle, deflection angle, narrow angle, deflection angle. Vertical horizontal plate. The 2/7 of the deflection plate of the plate to get the right angle to each side of the cathode ray tube with the figure 6 of the electron beam with control of the name of the direction by varying with the potential vertical deflection plate with the magnetism and spot beam with the plate of the tube move the vertical with the distance beam move the proportional of the chain with the potential differences between the plate with the chain with the potential difference between the horizontal deflection plate with the cup of the beam with the move the given distance from one side to the other directions other than up and down left to right with the chain with the combination for the horizontal vertical movement. Second order the tube with an envelope with the vertical deflection plate with the horizontal deflection plate's electron beam that's shown in the figure 6A the position X of the beam and the center beam with the position Y with the give it up to 2 units and the right units but move the beam is a result of those simultaneously action with the both sides of the deflection plate. The electrostatic field between the vertical plates move the electron up the amount with the portion of 2 units on the screen of this beam leaves capacitive between the horizontal plate. It moves to the right amount with the proportional 2 units of the screen. Vertical plane or horizontal plane. If the amount of deflection left down the curve of the set of the plate is actuated acted at the same time, the picture would be likely one view with the figure 6.9 with the example of the vertical plate with the move of the beam toward the stand with the X point at the rate of 3 units per second. The horizontal with the plate move in the left at the right with 1 unit per second. The movement that moves would be completed within 1 second at point Y. The result would be a straight line. Yeah. In view B, the potential for the vertical horizontal plane chain with the same rate with the same with the time period with the second. The both of the plates move the beam 1 unit with the horizontal plate with the hook plate with the check of the end with 1 second with the vertical plate that move the beam with the 1/3 of the required distance with the picture view B would be around the screen. Beam deflection plate action. Recall the start of the chapter 2 of the model of the waveform described in the term of the amplitude versus time of the you have the term of the have of the move of the cathode ray beam team depends on both the potential amplitude and time. Vertical deflection plate with the view with the extent with the explain with the action of the vertical deflection plate with single amplitude measurement. As discussion begins, remember vertical deflection plates are show the amplitude, the angle of the horizontal deflection plates are even the show time and the frequency relationship. Amplitude, time, and graph on the cathode screen representation. From time interval 0 to 1, vertical plate with the maintain with the static difference with the potential for the beam, stay with 0 with the time interval 0 to 1, chain with the cup with the increase with the potential difference, horizontal plate with the beam with the move 1 unit to the right, and time interval 1 with the potential difference, chain with the vertical plate with the curve with the cup with the beam with the move up with the instantaneously 2 unit the vertical amplitude beam location is maintained for the time interval 1 to time interval 4, horizontal beam move with the continue with the move with the right with the 3 units of time path with the time interval 4 with the instantaneous the negative voltage chain with the potential of 4 units the amplitude or curve of the beam with the move with the 2 positive units 2 negative units. Time interval 4 to 7 beams remain with the negative 2 units during the time period with the beam continue with the more moving horizontal right indicate the path shift of the time interval 4 time interval 7 then positive increase with the amplitude of the beam move with the vertical leave the negative 2 0 units of the time interval 7 to 8 with no chain with the curve of the vertical beam move. However, the horizontal move that continues within the time. Vertical plate with the potential difference allowed with the voltage of the waveform and horizontal plate with the potential follow the passage to get time together where they produce the image and trace that produce on the screen of the moving beam. Or your horizontal deflection plate with now look for the horizontal deflection plate. Assume with the position of the pentameter shown in the figure 611 is rated evenly along with the length of the arm for the diameter of the middle position for the same potential exhibit in each plate. So there's zero potential difference between the plate with electrostatic field that does not move downward at the uniform rate. The rate will become more positive than left that you're looking downward through the top of the cathode ray tube. Electron beam will move to the right of the screen with the screen point 0 from the points 1, 2, 3, and 4 when they equal the time intervals. Alright, horizontal plate with the top view with the negative positive battery cell with the negative positive electron resistor electron gun, vertical plate with the right pin left plate, the screens 1, 0, 1, 2, 4 marks, and the pentameter arm that move in the same way with the opposite direction of the right plate will decrease the positive potential until the beam return with the zero position at the point with the potential difference between the plate with is again 0. The move of the arm toward the other end of the resistant cup with the left plate with the plate with the power of the river with the right. The beam move of the screen 0 to 4. If the movement of the pentameter arm is uniform linear rate with the beam move of the uniform right at the end with the deflection plate with the bent outward with the wide angle of the deflection of the beam and the vertical plate with the bent down in the same manner. For easy explanation, manual move of the pentameter arm satisfactory introduce the horizontal beam move the head with the slope with the now vertical horizontal deflection of the accomplice beam with the volts with the produce with the much faster with the solid circuitry. You may want to review the solid tooth generation section of the Neets module line, introducing wave generation wave shape circuitry before continuing nearly all oscillate with electrostatic deflection applied with the solid tooth voltage horizontal position produce the horizontal deflection in the beam as shown in figure 612. Solid tooth generation right plate left plate trace retrace trace time retrace time flyback reference line amplitude. All right, in the figure solid tooth generation replay for the pentameter and connect with the both horizontal plate with the cathode ray tube. The reference line with the potential of the both plate is equal to below the line left plate with the more positive the high rate left and less positive the cover the beam to move to the left above the line over the right plate with the move more positive left the beam to move to the right with the waveform amplitude called the uniform move the beam across the screen called trace or retrace time shown at the trailing edge of the waveform and quickly deflect the beam back to the straight starting point. Or your cathode ray tube graticle achieve the previous discussion. Figure 6 with simply calibrated scale with the with the clear plastic amplitude versus time placed on the face of the cathode ray tube. The graticle can be used to determine the voltage of the waveform with the deflection sensitive the cathode ray tube uniform throughout the vertical plane of the screen. Deflection sensitivity say the number of the inch, centimeter, the millimeter of the beam will be deflected for each of the volt with the potential. The difference applied with the deflection plate is directly proportional to the physical length of the deflection plate with their distance with the screen inversely proportional to the distance between the plate with the second and the voltage. Deflection sensitivity is a constant with the dependent on the construction of the tube. The deflection sensitivity given the cathode tube might typically with the 0.2 of a millimeter per volt. This means that the spot with the screen will deflect 2 millimeter volts over the 0.008 of an inch with the difference of the 1 volt exists between the plates. Sometimes the reciprocal deflection sensitivity with the deflection factor is given in with the deflection factor, for example, given in with 120 volt per inch or 1 over the 0.8 thousandths. And above the example of 125 volts applied, one of the set plate will be deflected with the beam, the 1 inch of the screen, the means of the deflection cover the small signal with the likely to be observed, or this region of the deflection plate with the connected amplifier magnify the signal amplified with the vertical input of the scope. Assume for the example the peak value known with the voltage of the plate with the oscilloscope then indicate that each of the mark with the graticle will equal to the 60 volt even the 10 so the divisions will therefore equal the value with 6 volt for the most oscilloscope have the actuator with control of the degree for the gain control the increase of the strength of the signal before the plate on the deflection plate with the actuator for the gain with the same with the not undistributed but the calibration has been made for maximum accuracy. You should recalibrate the graticle each time the voltage to be measured. Alright, cathode ray tube designations. Cathode ray tubes are identified with the tube numbers such as the into API 3B 2API1 2AP1 2B P4 5AP1A. The first number identifies the diameter of the tube phase. The type of the diameter is 2 inches, 5 inches, 7 inches. The first letter designated in order the tube given the diameter of the ridge register the letter digital combination indicates the type of the phosphorus the glowing material used inside the screen with the phosphorus 1 or P1, which is used in most oscilloscopes to produce the green light with the medium of the persistence. The persistent refers to the length of the time the phosphorus glows after each electron being removed. The P4 provides the white light has a short persistence. The layer appear with the at the end of the screen the number of the modification after the original designation. Or your oscilloscope control component. The all cathode ray tube, the high versatile device that cannot operate without the control circuit. The diode of the control circuit that require the dependent of the purpose of the equipment. The cathode ray tube is used. There are many different types of the oscilloscope with a very relatively simple type of the instrument to high accurately laboratory model of the oscilloscope. They have different type of the circuit it must be derived of the basic circuit section shown in figure 613. 1 cathode 2 take a group of the control circuit that control the waveform 5 of the cathode ray tube, 3 of the power supply, 4 of the sweep circuit, 5 of the deflection circuit. Horizontal input of the sweep generator, the horizontal deflecting amplifier extension signal of the vertical signal input. Vertical deflection amplifier, sweep generator, horizontal deflection amplifier, cathode ray tube, basis vertical and horizontal power supply. Figure 614, drawing the front panel of the dual tray for the general purpose. The oscilloscope will also vary greatly with the number of the controls connected. Usually, with the more control of the connected, the more versatile the instrument. Regardless of the number of the oscilloscopes, if they have some of the control of the connected, the ones to learn with the fundamental operation of the common control, you can move the relatively even the one model of the oscilloscope to another oscillation. Occasionally, control of the server that serve the similar function label the differential one model to another. However, you will find that the most control logical group that their names are usually indicated in their function. Alright, this shows the dual tracer oscilloscope. The oscilloscope figure 614, the dual tracer becomes in between because the acceptance display with the two vertical signal inputs at the same time. Usually compare the two signals. The one signal with the reference signal. The oscilloscope can also accept with just one input. In this case, the signal trace oscilloscope, the following discussion will consider the signal tracing oscilloscope. The oscilloscope configure the commonly used the fleet. In the fleet, you're likely to use one of these module A and USM 425. The one very similar to it, and let's not look at the front panel controls. Or the component within the display with the waveform, the control cathode ray display screen with the display with the signal figure 615 allow you to make the accurate measurements with the vertical horizontal graticles as discussed earlier. Cathode ray display screen vertical graticles provide with the guided amplitude with the measurement. Horizontal graticles provide with the guide with the periodic time measurement. Components used to adjust the cathode ray display quality control with the figure 616 allow you to adjust the clear signal display with the allows you to adjust the display position, magnify with the horizontal tray with the factors to arrow both 10 times 10 to keep it in mind that the control will be labeled differently from one model to another depending on the manufacturer. Further, figure 616 as you study the condition control the description in the next paragraph. Our control position, vertical positioning on cathode tray astigmatus and focus. You adjust the well-defined cathode display the trace and rotation in line with the tray for the horizontal graticle position in the horizontal position of cathode display. Intended control of the brightness cathode ray tube beam. Finally, you locate the beam of the cathode display the 10 magnifier allow for the horizontal portion of the cathode display with the magnified 10 times. Intensity control. The intensity control sometimes with the call for the brightness to jump the brightness of the beam of the cathode tube. Cathode tube. The control of the rotative of the clock's direction. Increase the intensity of the beam that should be adjusted to the minimum brightness level of the conformal of the viewing. Focus astigmatus control with the focus control of the adjustment beam side with the astigmatus of the control of the adjusted beam. To the focus, the astigmatus control is adjusted together to improve the small, clearly defined circular style with display with the line tracing wheel. You with the same control with the well-defined line. Figure 6617 view A show down the out of focus of the beam. View B show the beam in the focus view. C and D show the out of focus and in focus trace them respectively. All right, shows A and B, C and D. Trace rotation control trace rotation control. Figure 616 should allow for the minor adjustment in the horizontal position of the trace that is line on the horizontal line with the graticle. Beam finder control of the oscillation trace will actually be located with the cathode ray tube up and down, left to the right, with the because of the orientation deflection plate. Be put the beam finder figure 616 pull beam out on the screen so you can horizontally vertical position control the center of the spot. Horizontal vertical position control. Horizontal vertical position control with the figure 16. You the position of the trace because of the graticle off the drum with the epicenter of the graph. Some of the oscilloscopes have the position control labeled corresponding x and y axis for the graph. The x represents the horizontal movement and y axis the represents the vertical movement. The figure 618 show the effective position control on the trace. A, B, C, D, and E, the effect of the horizontal and vertical controls. Alright, in view A, the horizontal control has been adjusted to move the trace to the far with the right. The view B, the trace has been moved to the left. The view C, with the vertical position control to discuss later adjusted to move the trace to the globe at the top. The view D, with the trace of movement has been closed at the bottom. The view E, with the figure 618 show the trace properly positioned. Alright, 10 times the magnifier switch. The 10 times the magnifier switch figure 616 allow the magnify the display signal with the factor with 10 horizontal direction ability is important that you need to expand the signal with the elevate it carefully. Alright, components used to determine the amplitude of the signal. When not discover the dual trace component of the discover the component that determine the amplitude of the signal. Notice that the figure 619 in the highlighted section of the upper left of the scope of the lower shift the same as the section lower left of the scope of the reveal of the dual trace the capability section of the scope of the upper left of the section of the channel 1 input with the same as channel 2 input with the lower left. The input with the both input at the same time will produce the two independent trace. The cathode ray tube dual trace capabilities of the scope. Position allow for the cathode ray tube display with the vertical, or move the vertical input with the connection of the input signal with the channel with the oscilloscope with the AC or grid with the DC with the input signal coupled with the channel with the oscilloscope. The volts division select with the vertical deflection of with the cathode ray tube is attenuated and control to provide this variable fine with the deflection adjustment between the calibrated settings. Uncalibrated indicate the warp, can indicate the variable positions of that volts in the division currently in the uncalibrated variable position. For the participants' introductory discussion we will present the cathode on channel 1, but you should realize that the information presented that also applies to channel 2. Vertical position control. Controls allow you to move the beam position up and down. Discover the earlier input, connect the vertical input, the signal input, the jack stem. The signal to be examined, the vertical deflection amplifier. Some of the oscillators may have 2 input jack labeled AC with the other labeled DC. Other modules may have single input jack with the associated switch, such as the AC grid DC switch in figure. The switch is used with the AC or DC connected. DC position signal is connected directly vertical deflection amplifier. AC position signal to the first five through the capacitor. Figure 620. Schematic with one arrangement. Alright, vertical input with the DC, AC, the capacitor, vertical deflection amplifier, cathode ray tube, vertical deflection amplifier, increase the amplitude of the input signal level of the required deflection of the cathode ray tube. The deflection of the amplifier must have any other effect of the signal to change the scope. Show the called the distortion figure 621. Show the result of the distortion occurring with the deflection amplifier. Input deflection amplifier output and actuator control. An amplifier can handle only a limited range of the input of the amplitude of the beam with the signal distortion prevent the oscilloscope the incorporation of the circuitry that permit the adjustment input signal amplitude level to prevent the distortion of the occurring. Adjustment of the actuator with the control of the oscilloscope of the volts of the division with the variation of the figure 619 with the control example of the usefulness oscilloscope being able to handle the wide range of the signal amplitude with the actuator with the usual of the two control one multiple position volt division control other variable potentiometer with the each position control may be marked with either as if the amount of the voltage is required to deflect with the beam and the unit of the distance of the volt division as in the unit amount of the actuation deflection factor given the signal such as 110 and 1. Suppose the negative 5 volt division position was selected in the position of the beam would deflect with the vertical 1 division every half volt with the applied signal. As the sine wave of the 4 division peak to peak amplitude would be 2 volt peak to peak forward by half an amp or half a volt as shown in figure 622. Same wave actuation, vertical actuated with the 12 volt division figure 619 provide the means of the adjustment input with the signal of the amplifier step with the sequence of the low with the high deflection factor the minimum of the control of the variation figure 619 provide the means of the fine with the variable control between the stop and the control may be mounted separately, may be mounted with the actuator control when the control is mounted separately with the alpha marked with a fine game with a simple game with the wind mount out with the actuator with control with the marked variable or variable control of the added actuation for the step with the select with the so simply calibration manometer is different than the variable control with the either left on marked with the front panels marked often in some of the conventional units of the 1 to 10 with 1 to 100 the actuator control that can be accurately calibrated to do. This you turn off the variable control with the remove of the from the actuator circuitry. This position usually marked with calibrated on the panel the associated light to indicate that the variable control is on and off. Figure 619 light with the call with the uncalibrated indicating the variable control is on the uncalibrated position. Alright, component 2 for the select vertical position operating mode that we discussed earlier in channel 1 being either to discuss the page for the operation procedure for the oscilloscope figure 620 they show how the vertical mode of the operation select with the vertical mode of the selection with the position button switch for the input to select the select channel 1, channel 2 with several other vertical mode of the operation for presentation discuss the note of the channel 1 is selected by these switches. So it has channel 1 and then alternator add chop channel 2 XR 200 megahertz bandwidth trigger review vertical mode push display only screens apply with the channel input connector. Alright, components you either determine the period with the type of the display with the type of the division figure 624 the control of the scope of the determine the period with the time of the display waveform the way we discussed earlier with the sweep generator developed the solid tube with waveform that is applied with the horizontal deflection plate with the cathode ray tube. The solid so with voltage cover the beam with the move of the crowd with the screen with the freight tray with the cover the sweep with the set the frequency with the time base for the oscilloscope the frequency with the time base variable with the chamber with the oscilloscope you accept the wide range for the input frequency again with the 2 controller U with the figure 624 1 multiple position with the time division with the chamber there's the frequency with the sweep generator and step with the second control with the pedometer variable the frequency between the step with each of the step of the time division control is calibrated with the front panel have the marking with the group the number of the microsecond and milliseconds. Time division select the horizontal sweep 10 max magnifier indicate the display sweep then with the magnified by 10 in uncalibrated indicator indicates the variable portion of the A to B time for physical control in the year and the variable the uncalibrated position. Variable provides the sweep rate between the calibrated setting with the time device settings. Pin number label the variable, the panel with the uncalibrated indicator label the variable, the control of the variable position. Desire they accurately measure the time of the cycle of one of the input cycle of the variable control of the calibrated position, the term of the time, the division switch, and the select the in appropriate time base. Suppose you choose the 10 microsecond position display with the 2 cycles of the input signal shown in figure 625. The one cycle that occupies 3 centimeter small division along with the horizontal axis. Each centimeter has value of the 10 microsecond. Therefore, the time of the one cycle equal to 30 microseconds. Recall the frequency of the signal may be found with either the following procedure. Frequency of the one over the time interval also 300 would equal 300. Time measure from the waveform time over the division. Selecting time base, you should select with the one with the lower frequency of the input signal. If the input signal requires the 5 milliseconds to complete one cycle, the 2 to the 7 to 5 millisecond per second, centimeter, 10 centimeter wide reticle. The approximately 1 cycle will be displayed. If the time of the base of the millisecond per centimeter, the approximately 2 cycles will be displayed. If the time base of the frequency higher than the input signal, only ports for the input signal will be displayed. And the basic oscilloscope of the sweep generator runs continuously free running and to move the out end of the elaborate oscilloscope normally turned off the oscilloscope. Or give the example of the sweep of the generator can be triggered at an input signal by the signal of some of the other short of the trigger will be just a couple later in the shaft. The type of the oscilloscope is all the triggered oscilloscope. The triggered oscilloscope permits more accurate time of the measurement. You may provide a more stable representation of the non-triggered type of the oscilloscopes. On some oscilloscopes, you will find 10 times the magnification control the previous as it also displays sweep the magnified by the factor of 10. Our components use to provide the shape of the display, the triggering level control, the the synchronize with the sweep generator, the input signal to provide the stationary waveform display, input signal, the horizontal sweep generator, or unsynchronized pattern with temperature, making the observation difficult. The A trigger control lower right of the scope of the figure 626 with the control of the stability of the oscilloscope with the cathode ray tube, the display of provide the permanent usual select source of the polarity of the amplitude of the trigger signal, the control of the A trigger, the level of the source, and the slope of the described on paragraphs. And then show the trigger selecting the amplitude of the point of the trigger at which the trigger is swept and trigger the slope of the trigger source, and the select of either the positive negative or the slope of the trigger to the sweep. Your source over the control, source control allow that you select the appropriate source of the trigger, and you can select the input of the signal channel 1 to 2 with the line 60 over the external input of the trigger level of slope and controls. The level controls allow you to select the amplitude of the point of the trigger signal, which for the sweep of the trigger, the slope of the select with the negative in position, and put the positive of the slope of the trigger signal at which the switch is triggered. Trigger level amount with the trigger slope on some of the scope determine the voltage required for the trigger and the sweep. For example, the trigger amount of the trigger is obtained with the signal display. The setting level of control to determine the amplitude point of the input waveform. This is displayed with the starting of the sweep of the figure 627. Show the display with the channel over there can be obtained with a different trigger with the level of the trigger slope of the settings. Level 0 the slope of the top of the view A, B, and B view. The show level of the 0 level the negative slope selection of the view C. Show the effective position positive trigger level the the trigger slope setting. The view D show the negative trigger level the setting with the positive trigger slope setting. View E and F show the negative slope setting with the difference of the view E have the positive trigger level setting, whereas F has the negative trigger 5 F has the negative trigger level setting. Slope A is positive 0, slope negative 0, slope positive slope and positive negative, slope negative the level of positive slope and level of negative. Effective slope and trigger level of controls. In most scopes, automatic function of the trigger tree allow for the front for rerunning trace without the trigger signal. However, when the trigger signal is applied with the trigger reverse for the trigger mode of the operation sweeper is no longer free from the action provided with the trace with no signal is applied with the synchronizing. Also, use the call of the free running condition with the trigger signal. The synchronizing not is the same. The triggering referred to the specific action of the event with an issue with the operation of the event. The operation will not occur. In this case, trigger with the sweep will not be also start with the trigger is applied with the succeeding sweep that must have the trigger before the sweep commences. Synchronization, however, the mean that the operation event is brought within a step of the second operation. Alright, sweep circuit is either the synchronization step of the triggers will either previously free running of the sweep to lock within step of the synchronizing signal. Trigger level control setting can be either increased with the synchronizing curve of the button until the time of the unstable pattern will appear with the cathode ray tube face. Alright, coupling section. The coupling section allows the use of the 4 position AC left rejection high DC AC portion is incorporated the coupling capacitor block and then DC component left and high frequency rejection point. The rejection low and high frequency components respectively DC position provides direct coupling of the trigger circuit. Is useful to when you use the view of the left and high frequency component of the signal components. Use the signal selecting scope trigger. The trigger mode with the shape of the 628 allow with the automatic trigger, the normal triggering. Automatic the trigger will free roam the absence of the proper target. Trigger the input, the will of the trigger, the input signal with the frequency of 20 Hz, the normal vertical channel input with the trigger with the sweep. Normal auto allow the signal above the 20 Hz, the trigger will sweep the horizontal sweep circuitry. Normally allow the vertical channel input signal to trigger the horizontal at the sweep. Components you with the select the horizontal deflection mode with the present of the note. The horizontal display figure 629 can be controlled with the time division switch with the only over the other switches section explained later in this chapter. Or your horizontal display provide the horizontal sweep display at the rate of determine the time division switch with the setting. Components you with the calibrate the probe with the scope of the figure 623. The components you with the calibrate the test probe with the scope of the A1 volt with 2 kilohertz square with the wig signal that provide with the for adjust the probe with the accurate square wave to the click of the vertical gain and the scope of the adjust the probe with the screwdriver that is shown figure in the figure. Calibrated provide square wave output with adjusting component with the scope of the probe to provide the test signal checking the vertical gain of the scope. Component compensation adjust the compensation test probe with the best possible probe with the scope of the impedance match. Similarity among the oscillopes. Oscillope you made you differ some respectively that one just cover the control of the main circle of the band identify the different many of the circles designed differently. However, the function of the fundamental of the same. Before you the oscillope, you should be careful to study the operator's manual that comes in with it. Alright, using the oscillope. An oscillope can be used with several different types of measurement such for the time, the phase, the frequency, amplitude, the observe of the waveforms. Earlier within the chapter, you learned that the oscillope is often used in study of the shape of the waveforms within the performance of the equipment of the being checked with the patterns of the oscillope of the scope compared with the signal. They should be paired with the 7th position according with the technical manual of the equipment under the test. You can then determine if the equipment is operating according with the peak performance standards. Or turning on the oscilloscope. Before turning on the oscilloscope, make sure to plug in the proper power source with the main scene. Obvious, many of the technicians they have to turn over the knob front panel with over the adjustment before they notice the power cord was not plugged in. Some of the scope of the power switches and probably the intensity with the control of the turn pull does not until they hear the click of the panel light comes on. Figure 613. Let's go with the warm up with a few minutes. Some of the voltage all circuit being stabilized, indicating that when the power is applied with the scope of the on, when the flash is light with the power pull with the power switch to turn the scope of the on and off. Alright, obtaining a pattern on the screen. When adjusting the pattern on the screen, adjusting intensity focus with the control of the bright and sharp line with the over the control setting, the start of the dot and start of the line, appear with the turn down with the intensity preventing burning the hole of the screen, coding with the different speed at which beam travel across the screen with the brightness sharp with the various focus frequency settings. For this reason, you may have to adjust the intensity of the focus with the control occasionally while taking the readings. The number of the cycle over the screen, the big cover the distortion makes it being at the end of the sweep. It's better to play for 2 or 3 cycle of the waveform on the screen instead of just one shown in the figure 632. And then show the proper signal presentation. The center of the 2-3 cycle provide that they will understand the waveform in the correct phase. Center of the 2 cycle presentation will be appeared inverted with the ability undistorted place waveforms and cathode ray tube. They will understand the relationship between the horizontal and vertical frequency, the relationship between the frequency of the waveform on the vertical plates and the soft the horizontal plate to determine the number of the cycles on the screen shown in figure 633. Input signal display 1 cycle, 2 cycle, 3 cycle horizontal sweep. The horizontal will the input frequency horizontal half input frequency horizontal third free input frequency. Alright, your horizontal frequency sweep frequency scope should always be kept lower than the equality of the wave frequency. This should never be higher. The sweep frequency where however the only portion of the waveform would be presented on the screen. If, for example, the recycle of the waveform wave were to be displayed on the screen, the sweep of the frequency should set at the end of the third frequency, the input frequency with the 12,000 Hz. The sweep frequency would be 4,000 Hz with the 3 cycle scope of the presentation. For the 2 cycle, the sweep frequency would set at the 6,000 Hz, and single cycle with the desired setting would be the same as the input frequency 12,000 Hz. Alright, the dual tracing operator for the information presented with the previous section. The general overview of the basic signal tray for the oscilloscope of the operation. You have the one channel of the operating control, but now you will be introduced dual tracing option. Dual tracing operation allows you to view the independent signals for the dual display on the single of the cathode ray tube. The operation will have the accurate mean of making the amplitude phase, the type of the display from the frequency comparison measurement between the 2 signals. Dual trace oscilloscope should not be confused with the dual beam oscilloscope. The dual beam oscilloscope provided 2 separate electron beams with a single scope with the individual jointly controlled dual trace refers to the single beam cathode ray tube that is shared by the 2 channels. Our components you select the vertical deflection operating mode. Vertical mode controls figure 634 allow the select the operating mode with the scope of the vertical deflection. Channel 1 input, channel 2 input with the coupling source level, the trigger valve with the display with a single level of the trigger display. Channel 1 alternating chop to cover the 2 XYZ with the sweep, the display with the 2 XYZ of the sweep. Channel 2 of the single play with the channel 2 in the connector. Our channel 1 and channel 2 with the control with the allow the display the signal apply with either channel 1, channel 2 discussed earlier. Trigger view with the trigger view allow the display with the signal that actually use the trigger to display with the trigger was discussed earlier. Alternator mode. Alternator mode figure 635 of the tank with the dual tray with the technique with the gate, and then between the sweep with the control with the allow with the signal apply with the channel 1 to be displayed with the intent with the channel of the 2 display with the entirety of the method display with the continued alternating between the 2 channels. The slow speed with the 1 trace being with the fade with the other channel being gave, but consequently the alternating mode is not even the slow speeds. Chop mode is shown in figure 636. The display next will not produce the satisfactory dual sweep high speed alternating mode's efficiency at the low speed. Therefore, they both are either dual trace oscillate for the components each of the other, give the scope the more dynamic range of operation. Channel 1, channel 2 applicator gate with the cathode ray tube sawtooth generation double grounded. Channel 1 amplitude gate and 100 kilohertz multi-vibrated cathode sawtooth generator. Output DC voltage reference the amplifier and independently adjust, therefore beam will deflect with a different amount with each of the channel with the voltage reference different with each of the amplifier output. The output voltage of each of the amplifier applied with the deflection plate of the gate, but the gate is actually an electronic switch and the application for the commonly referred to the beam switch. Switching control of the high frequency multiplier of the chop mode of this gate is select the output of the one channel. Therefore, the other high frequency rate of the 1200 kilohertz is most oscillate cover the switch at the time for a short good quality oscillate. The resultant display the 2 set of the horizontal gas line is shown in figure 637 view A. Our channel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Channel 1 and 2 display chop mode. Alright, your dash line channel 1 out with one of the channel, while channel 2 with the output with the other. The trace move to the left to the right because of the 12-tooth waveform applied with the horizontal plate. The more detailed analysis of the beams from the channel 1, channel 2 with the gate connected to the output with the one channel with the gate sample of the output channel 2 during the time 3 and 4. The beam is at a different vertical location. This is assuming that channel 2 with a different voltage reference of the beam will continue the separate sequence of 5, 6, 7, 8, 9, 10, 11, 12 of the race set with the one horizontal sweep. When chopping the frequency much higher with the horizontal sweep frequency number of the dash very large with the, for example, the chopping over the 100 kilohertz of the sweep frequency with 1 kilohertz. Each horizontal line will appear with as a series closely spaced out as shown in figure 637 view B. Sweep frequency become the lower compared with the chop frequency. The display will appear frequency trade, therefore the chop mode is with the low speed sweep rates. When signals are applied with the channel amplifier view with figure 638, the outputs are chained with according with the trigger signal view with the resultant pattern view see with the screen provide the time and base for presentation single of each of the channel. Channel 1, channel 2 they show the binary and dual channel display chop mode. Add the switch from the earlier 35 algebraic, add the 2 signal with the channel 1 and 2 together and display other dual tracing oscilloscope controls. Most dual trace oscilloscopes have both A and B with the time-based horizontal sweep control. The node of the upper right with the corner of the example scope of the figure 635 with coupling source level. The slope with control of the same function of the div of the same with the control of the time-based section with the scope of the base tape and base is selected by using the same A and B time division control pull out of the outer pull outer knob. Time of the B time base for the control of the horizontal display section discovered earlier in A time base. However, the experienced technicians generally do not use the A and B time base together and mixed or intensified or B-Lloyd delayed settings. These controls are fully with explained applicable technique. Therefore, will not discover the controls of this after the figure 639 with the block diagram basic dual tracing oscilloscope without power supplies. Alright, voltage division, channel A vertical, channel B vertical amplifier, beam switch, delay line, vertical output amplifier, show in the cathode ray group, the grids. You have your channel, this goes on the oscilloscope of the time delay, time diversion, time base generation trigger to the time base amplifier going to the grids. Your time base generator, unbalanced, unblocked amplifier, chop block amplifier back to the beam switch. And this channel A vertical and channel V vertical on this beam are the vertical volt division for the trigger checks. Or accessory, basically the dual trace oscillable that has one with the bit going, the sum of the two vertical channel they have there, have many of the variation horizontal sweep channel, the various some of the equipment, some of the one time base, the strip with the other have the two other independent, the sum of the oscillable, and the others are independent control of the oscillable modern general purpose of the oscillable or unit construction module. This is the most vertical circuitry contained with the remove of the plug-in unit, the most horizontal circuitry that contains the other plug-in unit. Main frame and oscilloscope is often adapt with many other special applications about the desired variety of the plug-in and assemble the modular feature of the provide with the most greater versatility than in a single trace oscilloscope for the inside of the analog of the character of the transistor can replace dual trace plug-in the model similarly conduct the curve of the trace and plug-in model. Other plug-in models available to some of the oscilloscope with a higher gain, wide bandwidth amplifier, differential amplifier, spectralizer, amplifier, psychological monitors, other specialized units. Therefore, the dual trace compatibility function type of the plug-in unit used in some oscilloscopes. To get maximum usefulness of the oscilloscope, you must have the means of the connecting desired signal with the oscilloscope input. They establish the chemical connections between any of the equipment output of the oscilloscope input. Variety of the probes available to receive the monitoring signals at almost any point within the circuit. The most common type of the 1 to 1 probes, attention actuation probes, and current probe. Each of these probes must be supplied with a different tips to allow the measurement of the signal with any type of the test point. Figure 6 for each of the many of the common probe unit tips. Or you have your probe assembly holder, straight BNC tip, and the plug tip, the hug tip, flexible tip, alligator tip, pincer tip, your probe, and 5-inch ground lead, 1.5 ground inch lead. Shoot for the probe with a particular arrangement that contributes to the factors, circuit loading, single amplitude sensitivity. The one probe that offers little no attention signal under tested is therefore useful for measuring low level signals. Have the circuit load with the 1-to-1 probe may be problem with the impedance of the probe tip. The same as input with the impedance of the oscilloscope. An actuated probe with internal high value with the resistor receiver the probe tip. Give the probe with a higher input pin impedance with the oscilloscope because of the higher input impedance of the probe. Can measure the high amplitude signal over drive of the vertical amplifier connected directly with the oscilloscope. Figure 641 shows the schematic representation basic actuation probe. 6 mega ohm resistor for the probe with the 1 mega ohm input resistor for the oscilloscope from 10 to 1 voltage divider. Our basic actuation probe, resistor 1 megahertz, capacitor, adjustable capacitor probe body, and then broken actuation probe. For the probe resistor, then serve the oscilloscope input with the resistance of 10 mega ohm with the probe. The actuator probe with the oscillation cover the less for the circuit load with using one probe. Before the actuator probe for the measurement of the high frequency signal for the fast rather than waveforms to the probe with the compensating capacitor according with the instruction for the applicable detecting manual. Some of the probe with the impedance equalizer and with the cable tap of the oscilloscope with the impedance equalizer according to the manufacturer's instruction that appear sure the proper impedance matching between the probe and the oscilloscope and then properly adjust the impedance to equalize the result of the erroneous measurement, especially whenever you're measuring the high frequency of the fast rising signal. More information on oscilloscopes and hookups can be found in electronics information maintenance. It's a book with an EMB test method and practice. A special current probe that have been designed by the electromagnetic field to produce the current that is the travel to conduct the type of the probe that's clamped around with the conductor without disconnecting it from the circle. The current probe is electrically insulated with the conductor from the magnetic field about the conductor and due to the potential current probe with the proportional with the current through the conductor. Thus, vertical deflection oscilloscope display with vertical will directly proportional current through the conductor. Alright, finally, your spectrum analyzer. The spectrum analyzer uses examine the frequency of the spectrum of the radio transmission local oscillator tests have the angular equipment operation for the testing frequency range where the experience will be able to determine the finite area of the malfunction components within the equipment. Successful spectrum analyzer depends on the proper operator for the spectrum analyzer your ability to correctly interpret the display frequency. Although there are many types of spectrum analyzer, we use the Tektronix model 492 for the artist of the spectrum analyzer except for the electronic input signal display of the frequency amplitude of the signal with the cathode ray tube with the vertical y-axis of the amplitude is plotted. The frequency would then be found in a horizontal x-axis. The overall pattern of the display figure 642 would indicate the proportional power presence, various frequency with the spectrum, fundamental frequency with the sideband frequencies. So once again, you have your amplitude frequency spectrum analyzer pattern. Basic functional description of the model 492 analyzer can be divided into 6 basic sections, followed by the converter section, immediate frequency, intermediate frequency section, display section, frequency control section, display control section, power and cooling section, converter section. The converter section actually consists of the frequency converter made with a mixture of the local oscillator, the required filter, the only one of the frequency converter that is time path of the root of the filter reach for the next converter. Analyzing the frequency can, however, be determined by altering the frequency of the L over the adding frequency control. Frequency converter the first front end of the converter chain with the input signal they use unusable IF signal either the 829 MHz or the 207 MHz. The I frequency is to be produced for the dependent on which of the measurement band selection of the current being used. The 829 MHz I frequency signal will be selected for the band the 2 through 4, while the 274 MHz I frequency is selected for the bands in 1, 5 through 11. Our second converter. The second converter actually contains the two converters. Only one of these converters is ever operational. So, as a result, the measurement band with the current being used, the second converter will be converted frequency received the first converter with the usable 110 MHz IF. It will provide the third converter. The third converter, the converter takes the 110 MHz IF signal and amplifies it, and then converts it to the final IF. The 10 MHz of the signal is then turned and passes in the IF section. Alright, the IF section receives the final IF stuff that you the resolution you select the filtering system resolution selected on the microcomputer control the 5 bandwidth 1 MHz 10 kHz 10 kHz 1 kHz 100 Hz. The gain for all the bands are level to logarithmic amplify the done each division signal chain with the cathode ray display the mean the equal and chain with the average division of the cathode ray tube. For example, the 10 decibel per division mode of each division equal chain with the equal to 10 different decibel difference regardless of whether the signal appears at the top bottom of the cathode ray tube. The signal needs to produce the video output. Display section is detected and provided. Alright, display section. The display section provides the representative display of the input signal from the cathode ray tube that comes with this by performing the following function. Receive the video signal in the IF section. The profit of the signal to be adjusted to derive the cathode ray tube. Receive the sweep the voltage profit of the signal to produce the horizontal cathode ray tube drive voltage plate voltage. Receive charter data information generated with the cathode ray tube derive the signal of the alpha and numeric characteristics of the cathode ray tube. Receive the level of the front panel beam with the control will generate unblinking signals to the control display with the presence of the brightness and focus. Or the vertical deflection of the beam and increase the output amplified director and detector increase the horizontal position control the frequency control section. The frequency analyze the incident of the beam switch to the left, the right, the low, high frequency during its analysis. During the analysis angle is discover the vertical deflection will show the strength of the signal at the horizontal position that is frequency. As a result, the display of the amplitude as a function of the frequency. Your frequency control section accomplishes the tuning of the first and second LOs within the section of the frequency immediately being analyzed. The control the current frequency of the LOs is analyzed. The frequency must change the LO frequency low frequency to allow the new frequency is converted to the 10 MHz signal section periodically unit sweeping analyzing frequency range center for the frequency set the frequency knob. The adjusted frequency now the low will be turned to the new frequency. Only the low frequency first two converters can be changed to the frequency being analyzed. Digital control section. All internal functions of the control from the front of the panel with the built-in microcomputers internal above the receiver produce all the communication and control any of the section of the analyzer. Powering and cooling system main power supply will provide the almost regulated value required to operate the unit. This display of the section provided the high voltage necessary to the cathode ray tubes. Cooling system allows the fresh air cool air to be routed and allow the section of the unit the proportion of the heat to generate each of the section. Alright, spectrum analyzer front panel control indicator the connector of the section will describe the function of the front panel control indicator connector where to complete the description each of the function refer to figure table 6.1. The review in the front panel figure 643 the number is located in the column table 6.1 equipped with the same number of the file in the front panel of the figure 643. Move the operational function of the spectrum analyzer the micropacitors are controlled with the switch selected with the redder and adjusted. Alright, 1 intended now control the brightness of the cathode ray tube. The cathode ray tube reads out the display for the electronic adjust the readout with the push button switch with the readout display the on and off with all the spectrum analyzer parameters described the wavelength expected time diverse the vision of the brightness of the display of the proportional time of the brightness can be reached up the internal controls only to be qualified technician. Gradial and the push button switch with the gradical light and on and off baseline clip of the push button the activated clip is subject to the intensity of the baseline. Triggering allow the area allowed one of the four triggering move of the selected pushing button to eliminate that within active depending of these four are selected the others are cancelled. Free run when activated sweep the free running without regard for the trigger signal in intermediate when activated sweep is triggered by a signal with the left edge with the display with the amplitude 1.0 division of the radical more line activated the sample of the AC power lines voltage of the unit trigger the sweep extension select with the sweep of the trigger with the external signal with the apply with the back panel with the inner horizontal trigger connected between the minimum and the maximum of the half of the 50 volt peak. Alright, signal sweep. The push button. Please read it. Indicate the number so that provides signal sweep the operation. The operation select the one sweep initiated after the sweep is uncircled will be been triggered. Push the button does not cancel the other trigger mode. The button sleeping signal. If first select the present sweep is aborted, but the sweep circuit is not yet armed. Additional push button is required. The initial arm sweep of the push button must be pushed again to rearm sweep the circuit. Each time the sweep has run to cancel single sweep, we must select one of the 4 trigger mode selections. 7 ready when when a single sweep is selected. The indicator lights when the sweep circuit is armed and ready for the trigger signal. The indicator still light is until the sweep is completed. Natalie's interactive ray tracer. Manual scan the time division number 9C. The selector for the minimum position of the control will manually verify the cathode ray beam across the horizontal axis of the display. The time of the division auto select sweep rate for the 5 unisecond the division, the 20 microseconds microsecond division. The switch also selects auto extension and manual modes. Auto mode this position sweep the rate with the select of the microcomputer, maintain the calibrated display, the frequency band division resolution video filter combination extension when select control all out with the external input. This will be used with a sweep rate and minimal when select with these control use the junction number 8 the manual scan number 8 10 frequency controls manually turned to allow the use to tune the central frequency range. The 2 push buttons are used to switch the central frequency up and down the frequency range that uses to play with the cathode ray tube readout. Alright, after the control issue for the measure frequency difference between the signals when the circuit frequency reads out goes to 0, when the read out the deviation for the reference of the next frequency signal is desired, the frequency knob is adjusted. Alright, 13 your calibration. You deactivate the frequency readout that can be calibrated. The center of the sum of the frequency adjust the frequency control with the correcting reading when they accomplish sure that deactivate the calibrated mode. DGAS for the when the button with the current logic oscillate the system reduce the 0 in order to minimize the magnetism built on low if this is down they enhance the central frequency of the actually you should do this verify every frequency chain before calibrating the center of the frequency. Identifying 500 kHz only. The significant identify the feature becomes functional only when the frequency band division instead of the 500 kHz activate the button. They have the 3 signal will change the amplitude with every sweep of the image pairs upon signal or shift horizontally or go completely off the cathode ray tubes and shift the stream amplitude every sweep. You should increase the sweep rate each sweep can be analyzed. 16 phase lock. The control button able to reduce the residual FM with the narrow of the span with select the narrow span of the phase lock can be turned off the back on the pressing on the button. Switching the phase lock off may cause the signal to shift position narrow span. The signal could shift off the display, however, it will usually return to the phase lock position after a few moments. The microcomputer automatically select the phase lock with the span division 500 kHz below the band 100 kHz below the band 3 with 200 kHz band 5 above. Auto resolution. The push button will be activated automatically for the band of the frequency span, the division time of the division video filter. The internal microcomputer select the band with maintain a calibrated display. This can be checked by the chain for the frequency span division or band with the chain display frequency span display division. This is continue with the attention control of the select with the frequency span division. The span division currently select with the display with the cathode ray tube. The span division selection depends on the frequency band section. So the band with the narrow span, wide span. 2 additional bands are provided with a full band maximum span 0 Hz span. When the maximum span is selected with the span display with this from full band with a 0 when 0 span is selected time division is read out with the instead of span division. Alright, 20 resolution bandwidth also continue with the control of the select the resolution bandwidth the cathode ray tube to display the range of the depth from the 1 kHz to the 1 MHz decade south of the also trim the resolution bandwidth within this control deactivate the auto resolution vertical display. There's 4 push buttons select the display mode with the scale factor be seen on the cathode ray tube division 10 decibel division each activated with the dynamic range display calibrated 80 decibel which either manager reticle representation 10 decibels. Alright, 20B 2 decibel division when activated will increase the resolution so that each of the major reticle division represents 2 decibel. Lane activated with the select of the linear display with between the 0 volts and between the reticle line with the reference level of the top of the reticle line select for the volt division C reference level to number 23A. Pulse pressure when selected increase the volt time of the pulse signal at the very narrow pulse of the line spectrum display can be observed. The video filter, one of the 2 narrow of the wide filters can be activated to produce video of the narrow band with the high frequency component of the display with the average of the narrow filter approximately 1/3 of the selected resolution bandwidth with the wide filter being 1/30 of the bandwidth activated, they either only will cancel or disable the complete switch filter off. Digital store 5 push button on the control operating with the digital storage function with the number of the push button activated. The display will not be stored. View be either the both of the push buttons or select the push button illuminate over the contents memory with the A and memory B, or display with all save the A mode off the tab and memory interlace with the tab B from DB memory. B save A activate the differential out of the arithmetic difference between the tab B memory with the save tab memory. A are displayed. Save the A mode activated. Save the A mode button will be lit. Alright, the max when activated digital store memory, the magnetic amplitude of the memory location permits the visual monitoring of the signal frequency of the amplitude relocation over the indefinite period of time. The feature of the user is measure the drift and stability to record the peak amplitude. Our peak and average the control selection of the amplitude which is the vertical display either the peak detected average of the video signal above the level of the control shown by a horizontal line cursor with the peak detected stored with the video signal below cursor digitally or average and stored. Minimal radio frequency actuation. This control is used in radioactive radio frequency bell transparency. The control uses to set the minimum amount of radio frequency actuation. Radio frequency level does not decrease the radio frequency actuation between the step of the minimum radio frequency actuation selector reference level. This continuous control requires for the microcomputer chamber the reference level 1 step of the each of the detection. Figure 10 decibel division, the vertical display mode with the step 1 decibel, the 20 quarter of the decibel, the fine mode with the number 26 is selected. Alright, your minimum radio frequency attentional decibel, so those value of the attentional level, the actual radio frequency actuation step of the microcomputer according to the logarithmic selection, but the minimum noise, minimum distortion number 27 of the button, radio frequency actuation, curve the chamber with minimum frequency actuation, microcomputer automatically changes. If the gain is to maintain the current reference level. Uncalibrated indicator light will display the amplitude no longer calibrated, selecting a sweep rate that is not compatible with the frequency expanding division resolution bandwidth. Logic and amplitude calibration. If the calibrated the dynamic range of the display logic calibrate for any logarithmic gain of the division, the decibel division amplitude calibrate for the reference level at the top of the gradical line with the top of the display. Find when activated the reference level the number 23A, the switch of the 1 decibel increment with the 10 decibel division display with a quarter of the decibel, the 2 decibel division both with 1 decibel linear display mode. Alright, 27. Minimum noise and minimum distortion. Select the 2 logarithms you can control the actuation at gain. The minimum of the noise button eliminate the reduce the noise level reducing actuation. Everything in the gain the 10 decibel the minimum distortion not limited to eliminate reduce the distortion to the minimum to observe any change of the radio frequency actuation display on the calibrated tube. Read out most of the 10 decibels higher than the main minimum radio frequency actuation selector. 28. The pull switch for the turn of the power on the extended radio frequency input with the 550 Hz coaxial input jack will use the input signal 21 GHz below. Some non-destructive input signal level that can be applied with the input with the 13 decibel meter 30 milliwatts signal above the 10 decibel make over the single core impression. 30 position. This controls you with the position of the display with the horizontal and vertical axis of the calibration output jack with the calibrated 20 decimal 100 MHz signal frequency mark with the space of 100 MHz apart with the calibrated megahertz mark with the reference calibration with the reference level of the log scale calibrate combination of 100 MHz marker UV to check out the span frequency radio output radio accuracy. Output first and second load. The jack that provided access to the output with respect to the load of the jack must be 515 ohms terminators to install the window not connect to the external device. External mixer. The external mixer button is activated by the provided output. The external mixer port for the external waveguide mixer. If the output from the external mixer is applied with the external mixer of the port with the second converter for use. 34 peaking. This control vary with the mixer for the external mixer. The external mixer mode. This code control should be with the maximum signal amplitude. Normal indicating upon power on power applied with the power not pulled out with the spec main light with the automatic on the microcomputer control with going into the following conditions. If you do not find these indications, these are the problem with it soon. Vertical display the 10 decibel division frequency 0 MHz. Reference level positive 30 decibels radio frequency actuation 60 decibel frequency range 0 to 1.8 GHz auto resolution 1 megahertz, resolution bandwidth 1 megahertz, frequency span division maximum, trigger free running, reading out on digital storage, view A and view B on. All other indicators off and inactive. Chapter 6.